Hello and welcome to the Depths of Wiki. So, the idea of this series is we're going to start off on a random Wikipedia page and use 6 degrees of separation, the notion that you are always within 6 degrees of someone else, but apply it to Wikipedia. And the idea is we're going to go through 6 different connections to each page, and by the end, we're going to find a topic. We're going to do a nice sort of useful 5-minute summary on that topic. The idea is we provide some good content that's useful, interesting, and who knows, might be even a bit educational, hopefully, for some people. So without any further ado, let's start off on Wiki Roulette. We'll start off on a brand new page here, just so it is random, and see where we wind up for today's topic. Alright, so we're going to start here, the River Till in Lincolnshire, in England's own country. Brilliant stuff. Awesome, so very detailed river map there, all very useful. But what we're going to do is we're going to find a random word to go with. Let's go for the National Rivers Authority. Nice and sexy. Alright, so that's 1. Let's go down to this guy, Lord Crickhow. He's number 2. And go to the Environment Agency. Okay, that's number 3. That's 3 degrees of separation so far. Let's go scroll really far, find something nice and random. Oh, emissions, always a good topical. Okay, so emissions is 4 degrees down. And then let's go to biomass for number 5. So we've got one more option to choose what today's topic is going to be on. And I think if we scroll down, let's have a look. We don't want to do one on humans. I reckon we go and do today's video on the Deep Carbon Observatory. All right, this is everything you need to know about the Deep Carbon Observatory in 5 minutes or less.
1,200 scientists, 55 countries, 1 decade of discovery. Carbon is essential to life as we know it on Earth's surface. But more than 90% of Earth's carbon lies deep underground.
Formed in 2009, the Deep Carbon Observatory, or DCO, as described by themselves, is a global community of over 1,000 scientists who are on a quest to understand the quantities, movements, forms and origins of carbon on Earth. So firstly, why carbon? Why is this of interest and the cause of such intrigue to attract over 1,000 scientists to understand more of its role within the Earth? Well, quite simply, it is the key feature for all known life. With the atomic number 6 and the periodic table letter C, carbon is perhaps one of the most common elements for school children worldwide to come across. As the 4th most abundant element in the universe after hydrogen, helium and oxygen, carbon's chemistry is involved in numerous aspects of planetary science. You know, carbon is an essential form for life as we know it, and it plays a critical role in Earth's environment and habitability. Carbon's abundance, its unique diversity of organic compounds, and its unusual ability to form polymers at the temperatures commonly encountered on Earth. What this does is it enables this element to serve as a common element for all known life. You know, it's the 2nd most abundant element in the human body by mass. It's about 18.5% after oxygen. So back onto the DCO. How was this formed and by who? Well, in 2007, Robert Hazen, a senior staff scientist at the Carnegie Institution's Geophysical Laboratory in Washington DC, spoke at a Century Club in New York on the origins of life on Earth. After this talk and various introductions to other leading scientists within the field, and after 2 years of planning and collaboration, Hazen and his colleagues officially launched the Deep Carbon Observatory in August 2009. So with the input from over 100 scientists invited to participate in the Deep Carbon Cycle workshop in 2008, they had expanded their original idea. No longer focused solely on the origin of life on Earth, the group instead clarified their position to further human understanding of Earth, carbon, the critical element to what we know derives life on this Earth. So how best to sum up the work and research of the DCO? Well, thankfully the DCO themselves have structured it into 4 specific areas of research. 4 science communities focused on the topics of reservoirs and fluxes, deep life, deep energy, and extreme physics and chemistry. Reservoirs and fluxes, described by the DCO as dedicated to identifying deep carbon reservoirs, determining how carbon moves among these reservoirs, and assessing Earth's total carbon budget. So the Reservoirs and Fluxes community, what they do is that they explore the storage and transport of carbon in Earth's deep interior. Why? Well, because it's a part of the Earth's makeup that is not fully understood even to this day. So what is described as the subduction of tectonic plates and volcanic outgassing are primary vehicles for carbon fluxes to and from deep Earth. But the process and rates of these fluxes, as well as their variation throughout Earth's history, it remains poorly recorded and analysed. So part of the key part of research here is the DCO's research is further examining whether large reservoirs of carbon may still be hidden in the mantle and the core of the Earth. So as such, they aim to get further understanding of just how much carbon is outgassed into the Earth's surface from the Earth's deep interior. Extreme physics and chemistry. This is defined by the DCO as dedicated to improving our understanding of the physical and chemical behaviour of carbon at extreme conditions, as found in the deep interiors of Earth and other planets. As part of this, resource discovery is so key to this goal of the community, with the seeking of new carbon-bearing materials in Earth a key motivator. Deep energy, dedicated to understanding the volume and rates of abiogenic hydrocarbons and other organic species in the crust and mantle through geological time. And finally, deep life, dedicated to assessing the nature and extent of the deep microbial and viral biosphere. So in summary, the deep life community documents the extreme limits and global extent of subsurface life in our planet, exploring the evolutionary and functional diversity of Earth's deep biosphere and its interaction with the carbon cycle. And so far to date, there have been some amazing findings so far. In December 2018, researchers announced that considerable amounts of life forms, including 70% of bacteria and archaea on Earth, comprising of up to 23 billion tonnes of carbon, live up to at least 4.8 kilometres deep underground. In summary, the Deep Carbon Observatory I think can best be described as a collective search to understand our Earth beyond what most would see, understand the core element of life and how it manoeuvres and changes our understanding of the world beneath us, and the impact this can have on our understanding, not only our past, but our future as mankind and the Earth. If you want to learn more about the Deep Carbon Observatory and the research they do, you can find them and their papers published directly on their website, deepcarbon.science. In the description of this video are some more useful links and references for further content around the Deep Carbon Observatory and links to the video material used in this video. So there we go, 6 degrees of Wikipedia have brought us to looking into the Deep Carbon Observatory, and hopefully you've got a start to an understanding of the work and research done by the DCO. With carbon as an element being the key component to life as we know it, perhaps the DCO will provide more answers for mankind in the future as we continue to understand our place in the universe and just how this home we call Earth truly works. Thank you for watching.